So we had to just do a few things. I asked you to define dew point. What did you write for the definition of dew point?
Temperature at which the water comes out of the air.
Okay, so it's the temperature at which water comes out of the air. When I say temperature at which water comes out of the air, what do I mean water coming out of the air? What does that mean? Water comes out of the air. Could be dew. Dew or rain or snow or fog. Yeah, or anything else that's water coming out. It is precipitation coming out of the air. So what's relative humidity?
Ratio between the amount of moisture in the atmosphere compared to how much the atmosphere shows.
Ratio of the amount of water in the air compared to how much water the air could hold. So it's a ratio of the amount of water in the air compared to how much water the air could hold. What does it mean if the air is saturated? Air is full of water. If the air is saturated, then what's the humidity? 100%. And then I think my wording was wrong, off here. What I wanted to know is when it's 100% humidity, what's happening? It's raining or precipitation or something like that. A lot of you put the air is saturated, which also fits. It's not wrong. It's not what I wanted. I wanted you to realize it was raining then. Did you have any other thoughts? Thank you. All right, back to this. For these dew point and relative humidity ones, I do think some of them could have been both. Some of them were clearly only one answer though. Which one's measured as a temperature?
Dew point.
That is dew point. How about how much water vapor the air is in the air compared to what the air could hold? That is relative humidity. Written as a percent? Yeah, relative humidity. Temperature of the air at which water will come out of the air. That is the definition of dew point. At 100%, when air is full of water vapor, it can hold. That describes relative humidity. Changes when the air temperature changes. It honestly, that's not it. For dew point, right now, if the temperature changes, the dew point would stay the same. With relative humidity though, and this goes with this picture that was on the questions back here. The relative humidity is 50% for all three of these. If I increase, let's just talk about this one. If I increase the temperature, what would happen to the size of the container if I increase the temperature? The container will get bigger. I'm going to try and keep my container the same width. So now my container might get bigger. So that's if I just increase the temperature, the container gets bigger. But how full will it be when I increase the temperature? Does the amount of water change? No, so it's still only this much full. Is it still 50% full then? No, it's not 50% full. Now it might be about 25% full. So what that question was saying, when the temperature changes, goes from being cold to being warmer, the amount of water vapor stays the same. So the relative humidity in this case was around 50. Here it's around 25%, even though it's the same amount of water. So that one's relative humidity. Always lower in a desert.
2 point.
Dew point will be lower, but still, I really think relative humidity would. I think in this case, I think either or would work.
I was thinking too.
How about increases when temperature decreases?
Relative.
That's relative humidity. Again, that goes back to this question. So if we look at a picture like this that has two containers, a warm container and a cold container with the same amount of water. So you're supposed to be seeing in this picture that they have the same amount of water. But if I take that water that's in the warm bottle and transfer it to the cold bottle, it's now a bigger percentage of it full. That's the same as our bottles up here. If I was to fill the warm air with water and make it 100% full, or even if I only had it 50% full, and then put it in my cold container would be 100% full. So increases when temperature decreases. That's relative humidity. How about can never be higher than the air temperature? That's the dew point. Lower when it's often lower when it's cold out. Nah, that one's gonna be dew point. Can we have 100% humidity when it's cold? Yes, so it's not always lower when it's cold out for humidity. But take a look at the dew point chart. When the temperature, do they say often colder when it's often lower when it's cold out? So if I take my temperature and I decrease my air temperature, what also happens with the dew point? It decreases. So 30, it goes down as we get colder. Usually higher in the morning than in the afternoon. Nobody? No.
Oh.
That one's relative humidity. Let's talk about this. Okay, so let's talk about this again in terms of these two containers, which relates to these two the actual containers here. I just haven't filled these with water. That's the only difference. So if I had my big container and my little container, and I filled each one with the same amount of water. In the mornings, what's happening in the morning? What do we know about the air temperature in the morning?
Cold.
Colder. So if it's colder and there's that much water, it's 50% humidity. But then what happens in the afternoon?
It gets warmer.
It gets warmer. Does the amount of water change that's in the air? No, but now it's less full. So if this container was 100% full of water in the morning, causing the dew, and then the air warmed up, this container now filled with 100% of water? No, that's only like what, like 30%, even if that, maybe 20. So the humidity is often lower in the morning than it is in the afternoon. Has a high value when it feels really humid and uncomfortable. What one? I just didn't hear what you said. That's the relative humidity. We have a high relative humidity when we're uncomfortable. Can be the same from day to day, even if the amount of water vapor changes. That again comes back to these three pictures. The amount of water vapor. So if I had, maybe that's not the best way to explain it. How is this one worded?
Can be the same from day to day, even if the amount of water vapor changes.
Can I, oh, yes, then this one's perfect. What's the relative humidity in all three of these pictures? 50%. Do they have the same amount of water vapor though? No, that small one only has only takes a little bit of water to make it 50%. So the relative humidity stays the same, 50%, but the temperature is different. So the amount of water vapor actually changes. That one's relative humidity as well. Now, we've talked already a lot about these. Which container is gonna be the warmest? The biggest one, so number 3. Why? Because it's the largest. If the temperatures of the air of the containers were to decrease, what would happen to their size? Yeah, they would also decrease. Because cold air cannot hold as much water as warm air. So it's just saying this is the warmest container because it's the biggest. This is the coldest container because it's the smallest. Which container represents the air with the highest dew point? Why? Because it is what? It's not because it's bigger, but it has, you're correct. Not why, but it has more space because it's warmer. The warmer the temperature, the warmer the dew point is going to be. What is the relative humidity of each of these? 50. That's because each one is 50% full. If you were going to give them a grade, they've got 50% of the amount that they could be holding. If more water was added to the air sample, which one would become saturated first? Number 1, yep. Because number 1 cannot hold that much water, so it becomes saturated faster. And when air becomes saturated with water vapor, what could happen? Could be rain. Yeah, precipitation, rain, snow, sleet, fog, clouds, all of the above. I like these pictures because we have 3 different air temperatures and then some water being shown in each one of the containers. What I like is the size of the air is biggest with the big one, but notice how the water vapor stays the same size. That amount of water vapor will fill up the 10 degrees Celsius air. There's some spare room with the 20 degrees Celsius and a lot of spare room with the 30 degrees Celsius. So which one of these can hold the most water vapor? Yeah, there's more room for water vapor in the 30 degrees Celsius one. Which one though is the air saturated? And what does it mean to be saturated? Full of water. So this one is that big, but it's all filled up with the same amount of water. So then what's the dew point for this one? It makes you think. If the air is saturated, what's happening? We answered that back here. If the air is saturated, what's happening? Rain or snow or sleet or fog. So if the air is saturated, then what do we know about the dew point? It's also 10 degrees Celsius. And remember, the dew point is the temperature at which water comes out of the air. So if the water's coming out of the air, the temperature and the dew point are the same. And finally, which one has the greatest chance of rain?
10 degrees Celsius.
And why did you pick 10 degrees Celsius?
Because it's full.
Because it's all full already. If we try to add more to it, it's going to overflow. And overflowing is rain. You were supposed to skip the bottom here. This one was just using the dew point and relative humidity chart. Hopefully this one was easy. I definitely caught some people making some very common mistakes second period though. So for this, I'm just going to go through, and if you have something different, let me know. The first one is 16 degrees Celsius. Then -4 degrees Celsius. Then for the dry bulb for this one, I got 12 degrees Celsius. Does anybody need me to explain that one? No? Everybody got 12? Who did it? Okay. And then we got 7 degrees Celsius.
Indeed.
Anything I can explain to help anybody out with that one? All right, then moving on, we got 54 degrees Celsius. No, we don't, we have 54%. 45%. 12 degrees Celsius. And 28%. Which one should I go over? Just three?
Yes.
Okay, let's go over this one. I was gonna pick a couple anyway, so I'm glad somebody volunteered this. So dry bulb of 20, relative humidity of 58, and they wanted to know the dew point. When you're not just flat out given the dry bulb and the wet bulb or the difference, you gotta work with what they give you. So they gave us a relative humidity. So I like to think of that normally as they gave us the answer. By answers, those are here in the middle, and we kind of have to work backwards. So the only thing they gave us was a dry bulb of 20. So a dry bulb of 20, that's here. But then they gave us a relative humidity. So, oh, and I'm doing the wrong thing here. So we want to know the dew point. So can I find that right away on the dew point chart? No. So I have to work with what they gave me. They gave me a relative humidity. So here's 20. If I scan through that, I can find that relative humidity they gave me of a 58 right there. Now that I've found the relative humidity, what else do I know? So now I know I can follow that up, and I know to get a relative humidity of 58 and a dry bulb of 20, my difference must have been 5. What can I do now?
I know the wet bulb.
Well, I do know the wet bulb is 15. Did I need to know that? Didn't need to know that. I do now know my dry bulb is 20. My difference is 5, so I go here, bring them together, and I'm right here at 12. So you do have to do those multiple steps to get this get to the answer. So hope any more that we should go over on that one? This was basically the same thing, except for you had to read the instruments provided. The Regents loves this. This is the way that I think they usually ask these types of questions, because it's two different skills: reading a thermometer and using the charts. They like that. So for this first one at the top, I got 12 degrees Celsius for the dew point and 58% for the relative humidity. Got those? Okay. 2 degrees Celsius. And what? No. You had 19? Oh boy, multiple people had 19. Maybe I'm wrong. So we've got 18 degrees Celsius and 10 degrees Celsius, and we wanted to do the relative humidity. So I'm just gonna use this chart that's right here. So 18 degrees Celsius. So that's this line. What is the other number I use? 8. 33. Those of you who got 19, do you know what you did wrong? Zach, look up here.
Yeah, I see now.
There's the right answer. There's what you put. What did you use to get the 19?
Okay.
You used 10. You used the wet bulb temperature. So I feel like I may have mentioned that everybody in this room will screw that up at least once. Please get it out of your system now, and don't screw it up on a test, and really don't screw it up on the Regent. You had to use the difference. You had to subtract 18 minus 10 to give you 8. And then you got to use 8. Okay. And finally, the last one, I got 18 degrees Celsius 69%.
Indeed.
You didn't have to do the bottom. But you know what? I'm actually gonna look at the bottom. Cause I did not intend for you to skip the bottom. That was an interpretation of a communication error between me and the sub. So let's talk about this chart. Guys, they freaking love graphs on the regions. Graphs that you've never seen before, but are not overly complicated. X-axis is time of day. It starts at midnight, goes to noon and back to midnight. Y-axis is the temperature on this side and relative humidity on this side. Then we have a relative humidity line and a temperature line. They'll use their own axis. What you need to notice is what's happening to the air temperature from midnight to like 6 a.m.-ish with the air temperature. Zach, air temperature is going down from midnight to 6 a.m. And then from 6 a.m. to about 6 p.m., the air temperature is going up, and then it steadily goes down after that. What is true about the relative humidity, though? What do you notice? When temperature's going down, what happens to relative humidity? It's going up. And then when temperature's going up, what happens to relative humidity? It's going down. This is still talking about different containers. How big of a container could we use to represent a cold air?
Small.
A small container. And then I'm going to go with a medium-sized container. And then a really large container. If the humidity was 100% when it was cold out, is that 100% when it's warm out, if it's the same amount of water? No, in fact, in my drawing, it's about 50%. And then when it gets really warm out, is it still even 50%? No, we're down to maybe 25% humidity. So as temperature goes up, what happens to humidity levels? It decreases. So the same amount of water just warming up the air, the humidity goes down. Now, to be honest, it's not quite that simple because the air humidity or the amount of water vapor can change due to other reasons. But if you were just magically able to keep the same amount of water vapor, the humidity goes down. All right, so that's just, I wanted to talk about that. So that actually leads us perfectly to this graph. When it's cold out, do we have a higher humidity or a lower humidity? When it's colder out, higher humidity. And then if we warm that same parcel of air, by the way, guys, do you know what a parcel of air is? Yeah, what's like, have you ever gotten a parcel in the mail? It's a package. It's how the post office calls that. They don't call them packages in the post office. They call them parcels. So it's a package of air or a chunk of air or a hunk of air.
Ew.
How do they call
Hunk. Hunk? I like to think of it as a hunk of air.
that?
What? Okay, fine. Don't think of it like that. But again, if you take that same parcel of air and just warm it up, the humidity will actually decrease. So cold temperature is going to give you a higher humidity. Warmer temperatures will give us lower. So that is that one. How about air temperature and moisture capacity? Meaning if we have cold air, can it hold more or does it have a higher capacity or a lower capacity if it's cold? Lower capacity. If it's high, does it have a bigger capacity or a smaller capacity to hold water? That one's bigger. When you warm air up, it's got a bigger capacity. Ooh, difference between wet and dry bulb and the humidity. Couple ways of doing this one, but I like to look right at the humidity charts. If we have a zero difference between wet and dry, what's the humidity? 100. And as we get to so really big, and then we get to a big difference, notice the humidity is really low. So that one, where'd that graph? That graph, if we have a zero difference, we're going to have 100% humidity. A big difference, we're going to have a low humidity. And probability of rain, have we talked about probability of rain? I think we have. Which one? Probability of rain. What humidity has the greatest probability of rain? 100%. So if we have this is the same x-axis here, 100% humidity, it's 100% possibility it's going to rain. That one's also a going down line. And finally, to wrap up your work from Friday, I'm going to just give you the answers to start with. And if you want me to explain any, I can. Number 1 is 1. Number 2 is 4. Number 3, 3. 4, 3. 5, 3. 6, 14. Does anybody want me to go over any of those? All right. 1 is 3, 4, 2, 3. Not 2. 1, 3, 2, 4, 3, 3, 4, 2. 69% and dew points.
Oh.
Any questions on any of those? All right. We don't have time to go over the homework. How about I put up the answers, you check them while I pass out your test.
Yeah, that's good.
No, you had a test on Friday, Monday. You had a test on Monday. Yeah, and I had them graded since the moment you left my classroom, and they never gave them back. Yeah, they should be right there. All right, so how about this? Why don't you open up to your homework? Mr. D will pass those out. I'll give you the answers. You only had to do every other because you had already done them. So the first one you did was the one that started with 20. 8, 4, 36. Then it was the 10 one. So 7, 4, 65. The next one you had to do, first of all, did you see that that was a -8?
Yeah.
Okay, so if you hopefully saw that that was -8, you would have had -10 and 2. And then 41. If you had here -6, yes, that's also a correct difference, or it would give you a difference of 2, but remember the wet bulb always has to be colder. Then the next one you had to do was this 0 one, so that would be -4, 4, -15. Then we had this blank here that starts with, it should have been 24, 6, and 30.
Yes, sir.
Then the 18, 10, and 2. And then the 25 one should be 24, 24, and 92. You need me?
92 is the dew.
92, no, that would be a temperature of night. That's the relative humidity. Did you have them switched?
Unless it is run.
Yeah, it sounds like it. And the last one would have been, first of all, did you see that those were negatives? And then the difference is 1, dew point is 13, and then I think that says 65.8, 68.5, sorry. And then to finish it up on the bottom, 21, 51, 81, 21, and 2. Answer 2, which is 7. Want me to go over any of those? Zach, were you wrong or was I wrong?
I don't know. What is the?
For which one are we
The
doing?
wet bulb depression, that means the difference, right?
Yes, the wet bulb depression means difference. So that time they flat out gave you the difference of 6. You would have done 20 and 6 in that case. And then this one, you would have used the difference of 6. Do you want me to go over them? Okay, let me know, Zach. The rest of you, grab your tests. I want to give you the correct answers. You have no new homework tonight. And we're just gonna go over the test right now.